on here. And off you go.
Right, thanks for that, Deirdre. Welcome to everybody to this Higher Application Mathematics workshop. I appreciate you giving up your time on a busy Saturday. I know there's lots of other things you could be doing today. So it's extremely nice to see you all here today. So what I'm going to do is I'm going to take you through the higher applications of maths and let you see what some of the questions look like. Now, obviously, what we've done so far is there's already been one specimen paper that's been released. Second specimen paper is due for being released. And what I'm going to do is I'm going to take you through, let you see some more types of questions that we're looking at for the second specimen paper so that you can have some sort of idea of what pupils are expected to or going to be faced with in the live exam. Also, what I'm going to do is I'm going to run through how to actually answer the questions, because a lot of the time it's not overly clear of how the questions to be answered, and hopefully this will give you some clarity. So I'll just start here. So the aims of today are to give you, the delegates, an overview of the types of questions that may be asked in higher applications paper, let you see how the questions may be answered, and finally, at the end, allow yourselves to see some of the support materials that will be available for teaching the course. So we'll just dive into the first question. The first question is a mathematical modelling question. And it's a fairly simple question. It's just simply estimate the number of hours of sleep a typical person in Scotland has during their lifetime. And then what we're looking for the candidates to do is ultimately just state any assumptions that they make in getting this estimate. So it's actually the assumptions here that are the crucial part of it. So if we look at the solution, pardon me, we'd be looking for the candidates to state an assumption about the number of hours sleep per night for an average person. Now, obviously, that's going to massively vary, but we're looking for some sort of ballpark figure. We would imagine 6 to 10 hours. If somebody says that they're a longer sleeper and they take longer than that, as long as they do some sort of justification, then that's fair enough. The next thing is state an assumption about life expectancy for an average adult. Now, again, depending on where in the country you actually stay, there could be huge differences to that. And we're allowing here for the life expectancy of an adult to be between 65 and 90 years old. However, we know that in certain parts of the country that 65 isn't achievable for some people there. So we obviously, again, we'll look at that in the context of the question, in the context of the answer. Use a suitable number of days a week. So obviously 365 days or 52 weeks. These are all the assumptions. And then finally, just them actually doing the calculation leading to an answer. So the appropriate calculation there would be 8 for 8 numbers of sleep, 8 hours of sleep, 77, just an average life expectancy of an adult, 365 days, leading to 224,840 hours sleep for the average person. So, felt that that was a nice wee question, possibly near the start of a paper, just lets pupils in, lets the candidates in, lets them see what the paper's about initially, and nothing great there, hopefully, to test them too much. And it's, again, it's all about this making the assumptions and stating their assumptions. So that's the first question. Second question is a finance question. Now, this question looks very similar to a National 5 question, but when we were looking at it and when this question was being designed, at every point we had to make sure that it went beyond National 5 maths, or in fact, in this case, National 5 applications. So what puts this question higher than a National 5 applications question? Well, even if we just look at it at the start, we know normally, traditionally, in appreciation and depreciation questions, in, oh, sorry, I don't know what's happened here. My apologies, I'll be back in a second. Sorry about that, computer decided that the life of its own. So, We know in our normal National 5 questions that an appreciation, it's going up by a certain amount for a fixed number of years. At applications, we know that it goes up sometimes for a fixed rate for 2 years and goes down by a rate normally. This time, if we look at it, it goes up by 3% per year during calendar years 17 and 18, 2% half year, and 1% from the 1st of July. So Donna makes a deposit of £500 into this type of savings account on July the 1st. Calculate the balance of Donna's savings on the 1st of January 2019. So it's definitely more complex than a normal National 5 maths or applications question. So the solution here is, first of all, they're investing the £500 on the 1st of July. The interest is 3% for 1.5 years. So the calculation for that should be fairly straightforward. And it's the 500 times 1.03 to the power 1.5, leading to their answer. And again, the difference there from a normal Nat 5 question is that it's 1.5 years. That's not something they would have seen before. So the next part of it is Donna makes further payments in and out of her savings account. So there's this process that's happening now. The payments are that on the 1st of January, she takes £100 out. On the 1st of January 2020, she takes 150 out. And the 1st of January 2021, she takes out £80. And the question here is, calculate the balance of Donna's savings account on the 1st of May 2022. So the solution. Well, on the 1st of January, we've already calculated that there's £522.67 in the account. £100 is now withdrawn, so that's the new balance. This balance earns 2% per half year until January 2020, then a further £150 is added in. So on the 1st of January 2020, the amount in the bank is simply given by the calculation, the 422.67 times the 1.02 to the power of 2 plus 150. And that leads to the answer that we've got there, the 589.745. This balance now earns a further 2% interest for a half year until the 20th of July. This balance is now given by the previous answer times 1.02. Then this balance now earns a further 1% for the next 6 months until the 1st of January. And the balance is given by the previous answer again times the 1.01 to the power of 6. Finally now, to finish it off, £80 is now withdrawn. The remaining balance earns 1% for the remaining 16 months. So it can be shown in the final calculation of 638.547, take away the 80, times 1.01 to the power of 16, leading to the final answer of £654.94. Obviously, that's a calculation that we would be expecting the candidates to do on paper in a similar fashion to the ones they would be doing at National 5 maths and applications. But hopefully you would all agree it's certainly far more complex than anything seen at those two levels, and that's what actually pushes it up into a higher level. Okay? So next question is a planning question. So what we're looking at here is, it's a nice wee follow on from our National 5 applications, where we've got the president's tables and the candidates have to fill in what are called PERT charts. So this time they're given the PERT chart already filled in, but with additional information that isn't there at National 5 applications. So the question for this is, explain using examples from this project, the difference between an activity which is essential for the project and an activity which is critical for the project. Well, the solution for that is an activity which is not in the critical path but is still required for the project to be finished is essential but not critical. And these tasks tend to have a bit more flexibility in the time constraints. So if we look back at the question, that is, we can see there with that question, we would look at our critical path and we would pick the ones that are not in the critical path. So the answers for that were A, E, and G. Then we'd be looking for them to answer the next part of the question, that B, C, D, and F are all activities in the critical path, and any delays to these would cause a delay in the whole project end date and are therefore critical. So we're asking them to make comments, but also supply us with some sort of evidence of why and relating it back to the question. Which ones are shown these examples? So, continuing on with the planning, the question is now going to ask them about the values in the activity A's nodes. So we've now got three values. We've got the 0, the 2, and the 3 in node A. So the solution for that is just simply the first value is the earliest time that the task can start at. So A is the first task, so it starts at time 0. The middle value in the row is the time required for the task to be completed. So that needs 2 hours for that task to be completed. And finally, the last value in the row is the latest possible completion time for that task. So although A only takes 2 hours to complete it, because it's done in conjunction with B and C can't be started before A and B are both finished, then the latest possible completion time for A is the 3 hours. The first one's actually is also called a forward scan, and that's the process we talk about getting those. And the end number, the last value in the row, is achieved by doing a process called a backward scan. So again, it's taken on the familiarity from National 5, but building on it to the next level of being higher. So the next part, still in this question, is now that the candidates have now been asked to produce a Gantt chart for this project. Now, all the Gantt chart is it's just essentially another type of visual representation for this planning task. It's fairly easy. They'll be given, obviously, paper to complete it on. They'll be given grids to complete it on, and they'll just fill it out like that. And we can see there, we saw from the table that A took 2 hours to complete the task, and B took 3 hours to complete the task. So for A, we've shaded in 2 boxes, B, we've shaded in 3, and C is not allowed to start until both of those tasks are finished. So B can only start when the last of those first 2 tasks is completed. So therefore, it starts at 3 hours, and it lasts for a further 4 hours. So that's a question we'd be hoping that the vast majority of candidates wouldn't have any great issue with. So our next question is another finance question. And this question, I'll just give you a second or two to read it yourself. Now, the question here, well, it's a finance question, and we're thinking straight away there's numbers there, we're looking for calculations here. The actual question itself is asking for justification. It's asking for 3 reasons why he may decide not to buy this insurance policy. Now, again, there are a whole load of options for this, and here are some of the options that we reckoned were correct solutions for this. So, £100,000 is likely to be insufficient to cover the cost of the building, given it's likely to have increased in value with inflation over the last 10 years. So, although he bought the flat for £100,000, in 10 years' time, you'd be hoping it'd be worth more than that. So if he only insures it for the £100,000, 10 years later, that might not be enough for to cover the cost of building it or rebuilding it. Insufficient amount to cover the contents, even if the property value has not increased over time. Policy doesn't cover all the perils. Fire's not mentioned. So we'd be looking for the candidates to look at that and say, well, what other things could happen to it? Now, if it's a top floor flat, you would hope that it wouldn't be affected by things like flooding from a river. But if it's a top floor flat, it could be influenced by flooding from something like the roof. So we're looking for the candidates to look at this policy and say, does it meet all the needs that they can think of? In this one, fire's not covered, so possibly not. They may prefer to pay a premium that's payable monthly rather than an annual cost, just simply to spread the payments. May be able to find a cheaper comparable policy with a different insurance company or using well-known insurance comparison websites. They may not want to buy a policy covering such a long period of time. For example, the rates might become cheaper over the next 5 years. So they may not want to lock themselves into that for that length of time. May be concerned that because it's a small new insurer, they might not last. That's why a lot of people go for large insurance companies, just simply because they know they're well established and they hopefully should be safer with them. But this, a new small insurer, there might be a bit of concern that something could happen to them and they might not be able to pay claims. May decide to take the risk and not buy insurance. Now, obviously, if they own the house themselves and they don't have a mortgage, that's entirely their choice. However, depending on where they live, they might not have that choice. So, for example, if they live in an apartment, a flat, etc., in a block, they would still have to have insurance to cover anything that happened to the building. So that's that one. So what was a finance question? We weren't asking for any calculations there. We were asking for the candidates to make the assumptions. So the next part, modelling. So an island generates its own electricity. There's a small wind farm and a diesel generator. Diesel generator is used when the demand for electricity exceeds the supply. The engineer who runs the system uses a mathematical model based on past data to predict supply and demand of electricity. The figure below shows the predicted rate at which the wind farm can supply energy and the predicted rate over a 12-hour period. So we've got the graph there. To answer it, the question actually is, state the number of hours the diesel generator is required during this period. Then the next part is determine the maximum rate at which the diesel generator should be able to generate electricity. So we've got our graph there. So what we're looking for here is, for part A, the answer to part A is obviously, it said state the number of hours the diesel generator is required during this period. That's when the use is greater than the supply. So it's 10 hours there. So if we can see, it meets at 8 o'clock, finishes at 6. So therefore that's 10 hours. The maximum difference between use and supply is simply the 1,200 for the use, take away the 400 for the supply, and that gives us the 800 kilowatts. That gives us our maximum difference. So it's them interpreting the graph here. The next part of this question, I'll let you read that and I'll put the question up. Or in fact, I'll put the graph up, sorry. So the question here is, determine the total amount of electricity used over this period. Now, if we look at the graph, the use part is a blue dotted line. So to calculate the answer for this, all we simply need to do is calculate the area under the use curve. So again, if I call up the graph, we can see here that we start at midnight until 9 o'clock. So from midnight till 9 o'clock, 100 kilowatts is used. From 9 o'clock until 9 o'clock at night, 1,000 kilowatts is used. And finally, from 9 o'clock at night until midnight, 100 kilowatts is used. So the calculation to get the answer for this is just simply given by the 9 for the 9 hours times 100 kilowatts, 12 hours times 1,000 kilowatts, plus 3 hours times the 100 kilowatts, which gives us an answer of 13,200 kilowatts. Now, the next part. We're now looking for how much energy the storage system must be able to store to meet the demand. So this type of question here, we're looking at, when it was originally written, it was looking at self-sufficiency for an island. So we're building in that sort of global context there, that islands are generating their own electricity and they're able to store it somehow. So determine how much energy the storage system must be able to store to meet the demand. Well, to get the answer for this, all we need to do is calculate when the use is greater than the supply. So again, the use is still given by the blue dotted line. The supply is given by the orange line. So what we're doing is we're looking here for the bit where the blue line is above the orange line. So from midday till 9 at night, the use is greater than the supply. The energy used is 1,000 and the rate of electricity supply is 200. Therefore, 800 kilowatts per hour needs to be stored. So the calculation now for this is simply 9 hours times 800 per hour means that we've got to store 7,200 kilowatts. So that is another mathematical modelling, and it was very much about reading and interpreting the graph and understanding what the graph meant. So next question is another finance question. Right, this is where it could all go horribly wrong for me here. So this one is, we have to refer to a spreadsheet. So the candidates are uncertain to know here that they must use the spreadsheet for this. So Carol has received a gift of £2,500 and is considering what to do with it. She's a savings account which pays interest at an annual effective rate of 1.25%. Calculate how much interest Carol would earn if she invested this gift in her savings account for 34 months. So this is part A of the question. So this still can be done on paper. So the first bit of this solution is, firstly, we need to calculate the monthly interest rate. Now, looking at a lot of the finance questions, this seems to be one of the most important things that candidates are going to have to do for the finance questions. And it's not simply taking the annual interest rate and dividing it by 12. So to calculate it, if the annual equivalent rate is 1.25, then the monthly interest rate can simply be calculated by 1 plus 0.125 to the power 12, or the 12th root, take away 1 and multiply by 100. So that now gives us that the monthly interest rate is 0.103%. The amount of interest after 34 months can be calculated by 1 plus that interest rate to the power 34, because it's 34 months, times the 2,500 that was the amount invested, take away the 2,500 to find that the amount of interest that she would get is now £89.56. So the bit again that makes this higher is converting that into the monthly interest rate. That's the bit that makes it harder. So the next bit is the bit where the candidates have got to use the spreadsheet. So she's got a personal loan. She borrows £8,000 to be repaid by level monthly repayments for 48 months. First repayment made 1 month after she took out the loan. Interest is charged at an annual effective rate of 4.9%. So we've now to open the loan worksheet, complete formulating the loan schedule, and hence calculate the level monthly repayment amount. So I'm going to, at this point, hopefully, come out of my PowerPoint. I am going to share the worksheet. So the candidates would be given, pardon me, a worksheet looking like this. So we can see it's got some sort of structure to it, but everything's blank. They have to fill in everything themselves. And remember, the actual question here is they're wanting to find out what the monthly repayment amount is on her loan. So let's start off here. So first thing is the loan amount. The loan amount we know is £8,000. So I'll simply put £8,000 into there. The annual effective interest rate is 4.9%. Then to get the monthly effective interest rate, so it's again the same as part A, so equals, but this time what makes it different and not a repeated skill is I'm now asking the candidates to do this on a spreadsheet. So it is 1 plus a C4 answer to the power of a 12th, take away 1. And that gives me the monthly effective interest rate. The loan period is 4 years. And ultimately, this bit in here, the monthly repayment, that is the answer that we're looking for. So what I'm going to do in there just now is I'm just going to simply put in a dummy monthly repayment. And I'm just going to put in any figure that I want. I'll just put in 200 because I like 200. So now what I'm going to do is I'm now going to start with the rest of the worksheet. So in here, the loan outstanding The loan outstanding at time 0 month is just simply the amount that we originally start off with, which is in C3 cell, which is £8,000. So what I'm now going to do is it's 48 months. So I'm now just simply going to take my months 0, 1, 2, and 3, and I'm going to increase that down so that I've got 48 months. There we go, 48. Now, I'm going to come back up here. I'm now going to go into this cell here, which is my cell C13. In C13, I want the repayment. So the repayment is going to be the same amount each time. So I want the absolute value for that cell C7 with the £200 in it. So I'm just going to put in my values. I'll put that in like that. And remember the equal sign. And there's a £200 appears in there. So the next part, the interest content of the repayment. Now, for this, what we want to do is, because it's money, we want it to round it to 2 decimal places here. So what I'm going to do is I'm going to use the round function. And I'm going to put in here, it's the initial amount that's outstanding, which is an F12. I'm going to multiply it by the monthly effective interest rate, which is C5. Now, I'm going to put it in, it's the absolute value for that. So I'll change that to the absolute. And I want to round that to 2 decimal places. So 2 at the end, close my bracket. And it gives me that the interest content of the repayment is £31.96. So now in E13, how much of the capital am I actually going to repay here? Well, all that simply is it is my C13, just type it in, minus D13. And I'll remember my equal sign again. That tells me that the capital content of repayment is £168.04. And finally, how much of the loan's outstanding? Well, that simply is, I've remembered the equal sign this time, is simply F12 take away E13. And that tells me how much of the loan's outstanding. Now remember, that's based on a repayment of £200, which is not necessarily the correct answer. So now what I'm going to do is I'm now going to copy this all the way down to the bottom. So I'll copy this for my remaining months. And there we go. So we can see by repaying £200 a month, we want to repay over 48 months. Well, we can start to see down here at this bit, in the 45th payment, you've now paid too much. So what we now want to do is we want to adjust this £200. Now, you could somehow do it by trial and error. It would take a long time. So what we can do is we can use a nice function that exists in Microsoft Excel. We can use a function called goal seek. So to get goal seek, we go to data. We go to this what if analysis over on the right hand side, and I choose the function called goal seek. Now, I want this bottom cell, this F60, I want that to have a value of 0. And what is it I want to change? Well, I want to change the cell that had my monthly payment in it. And that cell was C7. Now, this is a moment of truth. I press this and it'll either go well or it won't. And it's gone not too badly. And look at that. It's now changed a monthly payment to £183.49, which means that after the 48 months, we'll be at a value of 0. However, we need to go back and look at this monthly repayment, and we realise there that that is not how it's going to work in real life. It's not going to be to that number of decimal places, so we need to round it. So now we just go in, manually round it. It's what's that, 0.486, so manually round it to 0.49, enter that in. Look at the bottom now, and at the bottom, we're now 21 pence we've paid we've paid 21 pence too much. So now all we simply do is to this total here, we now simply subtract 21 pence, and that will give us our value of 0 now. So we can now say, by answering that question, we can now say that the monthly repayment should be £183.49. Now, obviously, without doing that on a spreadsheet, that question would be far, far too long. It would take a long, long time for them to do it. The paper is a 2.5 hour paper, but there's no way that they could probably do that in the time scale along with other questions. So I'll go back to the PowerPoint now. Hopefully.
Colin,
Yes.
there's been a few questions in the chat a little bit there. I don't know whether to ask that just now. They're obviously looking at saying, will there be any upskilling support on some of these things that you're doing in Excel at the moment? Because I think mind-blowing some of the things that people are saying here.
Yeah, and I fully appreciate where everybody's coming from there. It can be quite daunting. I would imagine people will be looking at that and thinking, whoa, I've never seen things like that before, or I've not seen that in a long time. What I'm going to do is at the end, I'm going to show where some of the support's available and what support we're actually putting in place to support teachers with this. So is it okay if I come to that at the end?
Perfect, perfect.
Okay, that's great, thanks. Pardon me. So, right, thanks, Deirdre, I've now lost where I am. Right, I'm back. Right, so
Sorry.
that's now, no, it's okay. That's now that question answered. So the next question is the next part of the same finance question. So now what happens is Carol decides she's just been given a £2,500 gift as a lump sum. And so what she's decided to do is she wants to see what effect will that have on her paying off her loan. So now what we have to do is we have to open up another spreadsheet and calculate our new monthly repayment. We've also got to work out how much she would save in interest by making this lump sum payment. So I'll go back to my spreadsheet again. And I'll share that. So the first thing I'm going to do here is I'm just simply going to copy this whole spreadsheet. So they'll be given a blank spreadsheet again on the next bit for part C. So it looks like that. And all I'm going to do is I'm just going to copy that on top of that, because obviously just now a lot of that information is still valid at the start. So what do I need to do? I need to now take into consideration that she's putting in a lump sum. So I'll just enter in there a lump sum, and the lump sum was £2,500. So I'll put that in there. The next part is I'm now just going to take in her new monthly repayment, and I'll put that will end up going in there. Okay, so now what we're going to do is it says here that she puts in the £2,500 gift after, just as she's made the 14th monthly repayment. So if I now come down to this here, here's the 14th payment. So she's made her 14th payment. Now she's going to pay in her £2,500. So I'm just taking that from the cell up at C8 that I entered in and put there, and that now changes this. That now changes that cell F26 to £3,322.54. Now, what that does mean is that means that all these payments afterwards are now going to have to change. These are going to be the new monthly repayments. So what I now need to do is I now need to change that from being cell C7 to now being cell C9. So I'll enter that into there. And again, I'm just going to copy that and paste it down for the remaining months. There we go. Now, as before, I'm just going to put a dummy number into the new monthly repayments. I'll just put £200 in there. And again, we can see that with paying the 200, it pays it off far sooner than she expects. So again, we use this lovely goal seek function. So I go to my data, I go to my what if analysis on the right-hand side, I click in goal seek, I'm changing, I want cell F60 again, I want it to be 0 again, and I want to change the cell C9 this time. So it's C9. Okay, that. And there we go. It's done an analysis again. It's left us with a 0 here. So next part, just go back up again, look at a monthly repayment, and just simply round that to 2 decimal places. Okay, now I should have formatted that for money, but I could go back and do that later. So now we can down here and we can see that we're still 7 pence that we owe. So now all we simply do is just add on 7 pence to that final payment. Oops, sorry, I've gone the wrong way there. So take this one here, add on 7 pence to the final payment, and that now brings us to a balance of 0. So we can now see that the new monthly repayment is now £104.70. Now, that's all well and good, but what we actually want to find out as well is the last part of this question is, how much would you save in interest payments by making this lump sum? So Carol's got to look at that and see what overall impact. She knows that it's ultimately going to save her some money, but she's got to decide herself whether she thinks it's worth it or not. So the next part is simply part C, part 2. So now what I'm going to do is into this bit here, I'm just going to put in total interest on original loan. Underneath it, just the total interest and adjusted loan. And finally, the saving. Now again, we're looking for the spreadsheet to do all our work here. So what we really want here is, we're looking for the candidates to realise that the answer for the first one, the answer for the total interest in the original amount is on the first spreadsheet that they've got. So all I'm going to do is I'm going to make that link. So I'm going to take it that it is from question 6, part B of the original loan sheet. And we're adding, it was D13 there to D60. That was the interest payment. So that will give us the total amount of interest. And I've made a mistake in it. Right, I'll try that again. Hopefully that will work this time. That's it, it's worked this time now. Okay, so I've obviously just made a wee mistake when I was doing that. So that is the interest in the original loan is given, but is £807.31. The interest in the adjusted loan, well, that's from this column here, that's from D13 all the way down to D60 again. So in this column here equals sum D13 to D60. Gives me that. And finally, the saving is just the subtraction of those two. That's it. And that's us answered it. So again, without the spreadsheet, that would be a massive, massive undertaking to expect a candidate to do that within the time scale of the exam paper. So that's why these questions are included in with the spreadsheets, just to allow the candidates that opportunity to use the tools that they would use out in industry or in real life for calculating these things. So I'm just looking at my time here. I reckon I've got about 10 minutes left. So what I'm going to do now is I'm going to just address that question that Deirdre was saying people had been asking earlier about the support there. Now, the support that's out there, currently running at Strathclyde University, there is an upskilling module in both mathematical modelling and in the statistics. They ran, one of them ran last year. So during the first lockdown, the statistics ran, then the modelling ran later on, but both of those are open just now. I'm not sure if they're still taking entries, but that's something you would have to look into. So both of those courses are there available. And the next part is one of the questions I'm asked a lot about is about courses for the higher applications. And obviously, there's not a textbook out there just now. There are a couple of textbooks that are available that meet aspects of the course, but they're aimed at the English market. So Scholar was given money by the Scottish Government to develop a higher applications of maths course. So for the last couple of minutes, I'll let you see this. So it's a demonstration model just now. It's not completed. It's still in the process of being written. So we can see there that we've got essentially the four main parts of the course: our modelling, our stats and probability, our finance, and our planning and decision making. Now, if we go to, for example, our mathematical modelling, we can see there we've got the introduction to it, and we can see all the different parts of it. We can see that there's about counting. So one of the questions I've not actually done yet was about daffodils and about estimating, but unfortunately not going to have time for it. And part of the thing was that counting daffodils, because it's a discrete object, what we do is we take an error of that of always plus or minus 0.5. And that actually tells you, within this course, it tells you all about that. It tells you that if you've got two relative errors, how to get the total relative error, just simply by adding them together. So that's what it's looking like from Scholar just now. Now, obviously, one of the ones that I was doing there, and that last question was a spreadsheet question. Now, that is very much in our finance. So if we look at the finance stuff here, we've got all about accumulation and present value. So we've got our normal Scholar stuff, our prerequisites and our learning objectives. And then it should feel very much like the National 5 and the higher stuff and advanced higher stuff that's out there. So I'll just give you a wee minutes here, or a wee bit of time just to have a wee look at this as I'm going through it. And I'll just select some. So it's asking a wee question there. I'll just select 3 at random. Covers me if I get it wrong. There we go. Only one of them's correct. Another 2 are wrong. And then there's a wee bit in here about a wee bit of feedback that'll be developed over time as well. So that's a wee bit of the finance. And there's nice wee examples there of how to do things. So from what I've heard from the writer from this, what he's planning to do is the support materials for teachers is going to be very much along the same line as the materials for the pupils. And what that will do is obviously give you familiarity of what the pupils would be asked to do. And obviously let you see the resources that they'll have as well. But it follows on quite nicely. If we keep going through it like that, we can see that he's covering all the different bits here. There's wee use of formulas in there as well. And he's got wee tips in there about rounding money. Okay. Then we've got the wee quiz. So it's as interactive as we can possibly make it, just allowing the pupils that wee bit of freedom to do it at home, but also, as I say, also allowing the teachers that professional development to look at this kind of thing. So if I come out of that one and go to the statistics, just look at this here. Again, it's just telling you everything that you really need to know. And obviously the big difference between statistics and higher application and statistics and National 5 applications is the fact that we're really not expecting the candidates to do manual calculations for it. Okay, the vast majority of calculations that the candidates are going to be doing some sort of software, using a software package, something like Minitab or something like R. And then if I just show you the last wee bit, so there's just bits that are in there for the statistics just now. Then the last wee bit is just simply the planning and decision making. So there's a wee bit, how to bake a cake and how to create a PERT chart based on that. And again, it's interactive. Builds it up so the pupils can see the thought process that's taking place there, and then continues on into the next sections, etc. About critical paths, about forward scans, about backward scans, etc. Okay, so I'll stop there just now, and I'll just leave the last couple of minutes just now. I think what we've got 3 minutes left for any questions that anybody wants to ask just now. Okay.
I think Martin wanted to have a few words as well.
Right, feel free.
Yes. Thanks, Deirdre. It was just to say the scholar material for finance will be available for all staff in June at some point, once it's been polished up and checked. So that will be made available, and to my knowledge, it's going to be free. That was all I was going to say. Thank you.
Okay.
Right, so does anybody have any questions that I may be able to answer?
There was one or two in the chat earlier on, Colin, that I took a note of. Something near the beginning about the rounding when interest is applied through time, you know, not the one in the spreadsheet, but the other one.
Yep.
At the beginning, is there any comment on that?
So what was the actual question? Sorry, Deirdre.
It's basically rounding, you know, it was a rounding, I'll see whether I can find it in this chat, whether what level of rounding is applied when the interest through time.
I mean, that's one that will obviously come out in the notes through the scholar as well, and something that we would look at. The people that are writing these questions are obviously the usual, we use writers that come from schools, but for this qualification as well, we've got a lot of support from our colleagues in universities who are specialists in these topics. So we very much are taking our sort of lead from them and what they recommend for the rounding, etc. So that's something that would certainly come out in time, and we would clarify near the times of the exams, etc. Or within, sorry, we would clarify just as people are starting to teach, etc.
I think that the stuff about upskilling on Excel, that's a lot of the finance stuff. So that's what Martin was talking about. It's going to be coming up from Scholar in June.
Yep. And there's also, as I say, there's also the 2 upskilling courses, one in statistics with Dr. David Young from Strathclyde University. I know they were certainly open fairly recently for applicants again. And there's also the one run by Dr. David Pritchard from Strathclyde University as well on mathematical modelling. The beauty of doing both of these courses is it gives you some, I think, credits towards further study as well. But obviously the big thing is it allows you a bit of confidence when you're going to deliver the higher applications course.
No cost to those courses. Someone was asking that. And there was a mention about was the exam going to be a mixture of paper and computer?
Yes.
So I kind of said yes at one point. Somebody asked that they need a computer suite, and then they're talking about whether they need R or could it all be done on Excel?
I'll be honest, I'm not sure. I would imagine R's certainly free. R's free, so R's certainly the one the vast majority of statisticians seem to use and prefer these days. So I would say, where possible, I would be looking to use R. But as far as everything that we need candidates to do certainly can be done in R. Whether it can all be done in Excel, I'm not sure.
I think there's certainly, I did the higher stats unit myself this year with classes, and I did most of it through Excel. But there, you know, I had to do there was, I can't remember what function, what hypothesis test it was, but there certainly was one of them that they didn't do in Excel. On there, and you can't do box plots. I like how minicab is so much easier. The predictor text. Minitab is a lot easier, but I think certainly what Colin was saying there was discussion around, you know, universities and others are going down the route of using R because it is free. So we kind of, certainly as in Highland, that's where I'm from, we've gone down the route we're going to purchase or get R on all our machines, because although Minitab is much easier, I think more people are using R in business and in university, so it's probably better.
Yeah, I mean, somebody's put in there as well, the big problem with Minitab is the cost of it.
Yeah.
That seems to be the biggest issue of it. But as you said, Deirdre, Mini R in our studio are free to download and free to use. And obviously the statistics questions that I prepared for the presentation, but unfortunately didn't have time to get through there. Obviously with them, the data sets would be given. So if you look at the criteria for the higher applications, there's things like create scatter graphs and box plots. And the initial reading of that, you think, well, wait there, that's a National 5 skill, certainly. And some of the things that candidates have been asked to produce would be a level lower than that. However, the big thing that pushes this up into the higher is the fact that they're using the statistical software to generate these, and they're not doing them by hand.
Yeah. So the Google Sheets thing, someone's saying is an alternative. Now, Google Sheets doesn't have all the formula capabilities.
No, we know that Google Sheets don't.
Yeah.
Myself and one of the finance experts are looking into that. There are other functions that are available, but they're not as good, certainly, as the goal seek. So one of the functions you can use to find in my spreadsheet questions the expected monthly repayment is a function called PMT, which you could actually use to get that payment. So that would work for that, but where that would become far more difficult is for the part C of that question, where the money's put in and the rate, or it's then changed later on, or if there's a variance in interest rates, apparently the PMT doesn't work particularly well or doesn't work for that at all. But we're certainly looking at other ways that it possibly could be done as well. But ultimately, the best way forward is the full Excel and the goal seek. It just makes it so much easier.
That people are asking whether they could use it, do Autograph if they had it, or SPSS, I think, is another statistical software. I don't think,
there's no specification of what software that they use. So I think my advice would be, as long as the software does what it needs to be, or what the question's asking, then that's absolutely fine.
And then there's the second specimen paper is coming out in June. Is that right, Colin? Did you say?
Yes, second specimen paper's coming out in June.
Yeah, I think there's a lot of we've had a lot of discussion. There's some discussion on there about not being able to do some of this on Chromebooks, and that is true. It is going to be difficult to do this on a Chromebook, if you're there all the time. Like if you're like, what are we doing? Lockdown at the moment. But it's just like the same as, if you were doing the admin course, or other things. There's certain restrictions to, you can get the Microsoft Office suite online through Glow, but I don't think there's still limitations to the functionality in Excel for that one.
Yeah.
So we weren't in the middle of the lockdown when we kind of put the course together and stuff like that. So I think it is one that's going to have to be done on a computer suite, or certainly having access to the full Excel software.
Using things like R, etc. It's not an exclusive tool of maths departments. We're doing the scoping for higher applications. It was something like 70% of non-maths and science courses require some sort of mathematical input into them. And a big chunk of that is statistical analysis, and departments all across the country that aren't maths departments all seem to be using R. So that was why, obviously, one of the recommendations is to use R, because it obviously has that twofold effect of, one, they can answer the questions for the higher applications paper, but two, if they're going on to university, they will already be familiar with the packages that they're using there, and it's not a new learning experience when they get there. It's something that's already there for them.
And there's other comments there about questions need to be written with the programs that are available in mind. Those,
but
there's only so much you can do with that one.
None of the questions have been written where the programs are not available for people to use. So, for example, if you're a Glow user, the full Microsoft Office is available for download.
Yeah, you could download it.
So the programs are all there for candidates to use.
One question I think they brought up earlier, I think we're going to have to stop soon anyway, because people are going to have to go to the next session. The level of literacy, but I think people kind of answered that in the chat anyway, in terms of, it's usually expected like National 5 level of literacy in a higher paper. I don't know whether you can hear my children screaming in the background there, sorry. But yeah, but that kind of got answered, that it is a big jump from National 5, but I'm going to stop talking now. Sorry.
Okay, so just parting shot, thanks everybody for attending this, and hopefully you feel a bit more confident with the types of questions that we're planning to ask in the higher applications. Okay, thank you.
Yeah, thank you very much, Colin. That's great. I said the slides, I think, will be put up onto the SMC website, and as well as a recording of this.
Right, thanks, Deirdre.
Super.
We problem at the start. I don't know what happened. It seemed to time itself, so if it took too long, it just moved on. But hopefully it wasn't too bad.
It was perfect.
Right, thanks for that, Deirdre. See you later.